All right, question 99. Sloan is a fraction wizard and prefers to convert all numbers in any problem to fractions. But her teacher insists that she be able to do Mr. Garcia's problem with decimals as well. So Sloan knows that 9 inches is the same as 3/4 of a foot. All right, so 9 inches, 3/4 of a foot, um, because there are 4 sets of threes in a foot. So we've got this idea. So let's just underline that so we remember that. So she first wrote Garcia's problem as 16 over 3/4. So we're going to take that 16, which was the length of the whole board, and we're going to divide it by 3/4, which is the same thing as dividing by 9 inches, but it's 3/4 of a foot. So we've got this really ugly looking fraction, 16 over 3/4. I suppose I could use decimals, Sloan mode, but I know the decimal equivalent for 3/4 is 0.75. So she then wrote the division as this. So now, give myself a little bit of room, she writes it as 16 over 0.75 because 0.75 is the same thing as 3/4. All right, so now we got decimals in our fraction. So here's what we have going on. Then she wrote the division as this. So she has 16 is still on top. And then she said, all right, well, I know that 0.75 is the same thing as 7,500 hundredths. So she wrote that as 7,500 hundredths. So 16 over 7,500 hundredths. So I know this looks kind of weird, but notice what we have. Here's my fraction bar. So we got 16, which is the length of the original big board, 16 feet, and we're going to divide that by the 3/4 of a foot. 3/4 is the same as 0.75. 0.75 is really 7,500 hundredths, so we're just converting this into this fraction. So we've got this fraction inside of a fraction. All right, so here's the meat and potatoes of this. So now it tells us that which giant one would you have to multiply to change Sloan's fraction to a fraction with integers? So here's what we want. We really don't want a fraction inside of a fraction. We want to get rid of this fraction. So I need to come up with some type of giant one that'll get rid of this. So I'm going to be really sneaky about this. And here's what I'm going to do. I'm going to multiply this by its reciprocal. So I'm going to flip it upside down. 100 over 75. So yesterday we talked about reciprocals, is taking a fraction and flipping it upside down. So I'm going to multiply by this reciprocal because look what happens here. Cross cancels. On the bottom, we just end up with a nice little 1. All right, so the bottom of this fraction just became 1. Make that a different color. So as we do this, or you can think about this as being 7,000, if we were to multiply this, 7,500 over 7,500, anytime you have the same number on top and bottom, it gives us 1. I like to think about all of this as kind of cross-canceling out. 75 goes into 75 once, 100 goes into both these once, and then look what you end up with, 1 over 1, which is 1. Now, here's the key to this. If I'm going to multiply the bottom of this fraction by 100 over 75, then I have to do the exact same thing on top. So I'm going to multiply the top by 100 over 75 also. Because remember, whatever we do to the bottom, we do the same thing to the top. Just like over here, if I had 2/3, all right, when we find common denominators and stuff, we've always done this. If I multiply the bottom by 5, then I got to multiply the top by 5. And that way we have two fractions that are equal to each other. So 10/15 is equal to 2/3 because we multiply the top and bottom by the same thing. So we're doing the exact same thing over here. I'm multiplying the bottom by 100 over 75. I'm multiplying the top by 100 over 75. All right, let's get rid of this. All right, so now watch what happens here. So when I do this multiplication, 16 times 100 over 75, it may look ugly, but actually the math isn't that bad on this because look what happens here. So I'm going to erase this 16, and instead I'm going to write it as a fraction, as 16 over 1, because that means the same thing as 16. I can multiply 16 by 100 pretty easily. That is 1, 6. 16 times 1 is 16, and then we add on our 2 zeros. So it's 1,600 over 1 times 75 is 75. Now, you might be saying, yep, this is still kind of ugly. I've got this fraction bar right here, and I still got a fraction on top and a 1 on the bottom. But anytime something has a fraction has a 1 on the bottom, it's just this. Like if I was going to do 2 over 1, that just equals 2. All right. If I have 6 over 1, that just equals 6. So anytime I have something over 1, then this is what it simplifies down to. So really, this becomes 1600 over 75. Now, notice how we got rid of that fraction, the fraction that we had earlier. So that's kind of what part A is talking about. So what giant 1 would we multiply to change Sloane's fraction to a fraction with integers? Well, this is my giant 1, 100 over 75 over 100 over 75, because this is really a giant 1, because we got the same thing on top, same thing on bottom. Let's see, do we answer your question? So which giant 1 would you multiply to change Sloane's fraction to a fraction with integers? All right, we answered that. Multiply the fraction, record your answer. So this is the answer we get when we actually do this. So there's A. B, decide with your team if 1600 divided by 75, that's our answer over here, is the same as 16 divided by 0.75. All right, so let me clear up the stuff here. So here's what they want to know. Get rid of all this stuff that's kind of in our way. So what they're asking is this thing that we started with, that 16 divided by 0.75, is that equivalent to 1,600 over 75? And my answer to that is yes, because here's what we really did. Are these two equal? Sure. If I do this, I multiply by 100. So if I multiply this by 100, we just slide our decimal 2 spots to the right, and we get 75. If I multiply this by 100, we'd have 16 with 2 zeros. So notice how these two pieces are equal to each other. All right, lots of stuff going on, I know, in that problem. All right, hopefully, though, you just kind of followed along. This giant 1 idea, I had this fraction here, so I multiplied by its reciprocal, a 100 over 75, and then I multiply the top also by 100 over 75. But notice that this thing that we had, this is equivalent to what we got. All right, it just looks different because we multiply top and bottom of this by 100. Part C, write Sloane a note explaining your answer to A. Include the steps to complete her work. We did that. We talked about that. So I think we're good. Lots of stuff in that question.